Welcome. This video will discuss how to compute new variables from other variables in a dataset. In order to follow along, you will need the SPSS dataset pulse_step3.sav after translating the original coded categorical variables. We already have the data open. We will begin with a common transformation which is often used in practice, the natural logarithm. This transformation is sometimes used to create a variable which is more symmetric than the original variable. We will use the original variable, weight. To do this, we go to Transform, Compute Variable. For target variable, we record the name of our new variable. Here we will call it LNWT. In the numeric expression, we can either type in our formula, if you already know how to specify in SPSS, or we can choose the function from the lists under Function Group. In this case, the function for the natural logarithm will be under Arithmetic. Clicking on Arithmetic gives a list of possible functions in the area below. We will choose ln by double-clicking on it in the list. This will bring ln ? into the numeric expression area. We then need to select the variable weight by clicking on weight in the list of variables. You can drag, double-click, or use the arrow to pull weight into the function. Once we know that the function is ln, we can simply type in the correct formula, ln parentheses weight parentheses, in the numeric expression box instead of choosing functions and variables. Once you're happy with your formula, click OK. Looking in our data view, we can see there is a new variable at the end called LNWT. Going to the variable view, we can give this a descriptive label such as natural logarithm of weight. To see the effect, we can compare the histograms and box plots for weight and LNWT. We can easily see that where weight was skewed right, the new variable LNWT is much more symmetric. These sorts of transformations have advantages and disadvantages, so be sure to read more about any transformations you plan in practice in order to fully appreciate the ramifications. Now we will create a variable for body mass index, which we will call BMI, from the height and weight variables in our dataset. The formula for BMI is the weight in kilograms divided by the square of the height in meters. Our weight is in kilograms, but our height is in centimeters, so we will need to divide it by 100 to get the height in meters. Let's go back to Transform, Compute Variable, and reset the tool. We will name our new variable BMI in the target variable. We will simply type in this equation, except for using the arrow to bring in the variables as needed. The numerator will be the weight, so we select it from the list and bring it into the numeric expression area. Then we need a / for division. Since we have a more complex denominator, we will put parentheses around it. Inside the parentheses, we will select height and then divide it by 100. We could use powers, which in SPSS is a double asterisk, ***, but instead we will simply multiply again by height divided by 100, using star for multiplication. So our final formula is weight divided by parentheses height divided by 100 times height divided by 100, close parentheses. Click OK when finished. In the data view, we can see the new variable. The values seem reasonable given what we know about body mass index. Finally, we will give this a label, body mass index with units of kilograms per square meter. We can compute many variables this way. Another possibility would be to construct standardized versions of a variable by taking the variable minus the mean divided by the standard deviation. Let's save this file as pulse_step4.sav. That's all for now. Thanks for watching.